So quick announcements before we start the lecture. I have an extra credit assignment for if you are available to attend. It's gonna happen on Thursday. FBI is gonna do some live demo with some form of security activities. So I'm assuming that they will do some hacking live demo. So that will be interesting. It's going to take place in Fontana, just like if you attended last year when you find it the same location. It's going to be 10 to 12 on Thursday morning. There will be a little bit of light food or brunch. They do a good job hosting, so it's a good opportunity for you to go and kind of network with professionals there. If you have your business card or resume or something, you can bring it and kind of introduce yourself to some of the professional and or connect with them on LinkedIn. I will try to come for the session, and then I'll come back to the campus later in the afternoon to teach a class. But if you are attending, I just need your picture, like a selfie, or if you take a picture when you enter the door, they have like a little area where you can take picture. You take picture with some of the people there. You can just submit it as for extra credit. And then I added in the announcement, I'm not sure if I wanted to add it as an extra credit yet, but Cal State San Bernardino is having an open house on Friday, the 25th, which is the following day after the summit. They have some expo events. I think there will be some guest speaking. Their focus is going to be on cybersecurity and AI, kind of interesting. If you go there, you will find that they have clubs and a lot of different things like drones and events and really cool things. So if you like to attend, if you're planning to transfer, it's probably ideal that you go and check out the programs that they have there. They have variation of the cybersecurity program. You can register using the QR or visit their websites. They are part of a lot of different organizations and different things that they do. So check that out, right? I'll think about making it an extra credit assignment. So if you go, you can get some extra credit if you want. Okay. So it'll be fun if you're free on Friday and stop by Cal State San Bernardino. Their cybersecurity center is nice. They've received quite a bit of money in the last few years, and we support them on their apprenticeship expansion. So they have scholarships and different things. So if you're interested, check that out. Okay. And then check out the cybersecurity summit ones. All right. So let's get into today's assignment. We're going to do a little bit of subnetting. And then if we have time, I will go over maybe an exercise or two in the workbook. That's an extra credit. And then you can take that workbook and work on it so you can get a little bit more practice. Because of the holidays, we are a couple weeks behind, but we should be able to get caught up pretty soon. So, okay. So this week we're gonna work on subnetting. We do a couple of the exercises. We'll do the assignment, and if we have time, I will give you a start on the workbook. And then we'll do a lab on packet tracer, continuing from last week. You're gonna find that we are going to program the router a little bit, and then use the cable to connect the switches, so you kind of have a logical understanding of how things are laid out and how to use the CLI in Cisco routers and switch. So if you have your assignments downloaded and notes downloaded, we'll take a look at those. So this is chapter 8. It goes over subnetting, and subnetting can be challenging for some people. If you go for Cisco certification, you're required to understand subnetting. I think Network Plus is not so much, but you need to understand subnetting for IT work and also cybersecurity. We use subnetting to isolate the network through the IP address configuration. We also use subnetting to be able to expand the network with the existing IP schematic. Instead of ripping out everything and then reconfigure everything, that is just not feasible. So subnets has its benefits, and back in the day, IP version 4, it still is limited, but the subnet understanding or knowledge or the skill sets is really implemented so that way we can use more IP addresses with the existing subnet mask. It is a way that we can tweak the subnet mask with the current IP address that we have so that way we can scale or expand our network. So subnet is a way that we can divide up locations, or we can separate areas of our network using routers. So if I'm in a different segment or subnet, I need to be routed into certain area. You see this with virtual LAN, and also you would see this on the physical network where we can add the network appliances so that way we can have segregation within the network for security reasons or for access reason. You don't want everything to be clumped up into the internal network without proper protection. So this is a big aspect for network engineering, and it's important that we understand how to implement it. And it's also a way that we can streamline some of the network traffic in that we can decide on a certain part of the network will utilize a lot more bandwidth compared to other parts of the network. It is a way that we can divert the traffic in a certain, actually on purpose, so that way we can make sure that our network performance is ideal. And so outside of separations and being able to reduce some of the network traffic, because if you don't have a need for it, right, why do you utilize the maximum bandwidth for a certain area? We can also logically set up the routers to separate certain part of the network, as we mentioned, right? Like your call center can be separated from your manufacturing area. If you're looking at some of the manufacturing company, like they have product customer service that goes to the call center, which is a separate part of the network compared to the manufacturing floor plants, or even shipping and receiving and so on. Okay. And so with that, we would need to implement what's called masking, and we would need to utilize the bits, right? Coming back to what we talked about a few weeks ago on how we would change up the host and the network bits, to be able to have separate subnets or different smaller networks. So for the first question, it asks you to describe the purpose and the benefits of subnetting, right? We want to take the IP address range or even the current IP address that we have, and we want to divide that up into subgroups, or what we say multiple address ranges. And those groups are going to be implemented as separate networks. So that means that we don't just have one large classful address that we're using. We want to have smaller subnetworks so that way we can manage them differently. This is going to help security. It's going to help us to control network performance. That means that we can, and you can clip that from the first page instead of retyping it. That means that we can have it in different locations. So if I'm looking at an enterprise or a corporation like Walmart, right? You have stores, you might have multiple stores in the same city, if it is a large enough city. You might have a distribution center and a couple of stores in one city. So within that, you would see that it is in the larger part of the network, but we don't treat them as one entire network, right? We treat them as subnet of the larger network. So that way your distribution center, their data access is going to be different than what you see with the retailing stores, right? Or shipping and receiving, the warehouses, that's going to be different. So that way you will be able to separate the networks for its functionality. Because you would see that maybe your online store for Walmart that is at one location that's hosted, right? That will be web front. It would require certain resources compared to what you see with the retailing store, the physical brick and mortar store, right? We still have to have systems that process transaction, inventory system, right? You know, and then you also have the online ordering components with the apps. So with that, you kind of have to think about the purpose and the functionality of your subnet and how your subnet is contributing to the larger network. And then we mentioned that it would help with reducing traffic in some area, right? If you have bandwidth to spread across, and some part of the network might not require as much bandwidth compared to what you see in some more intensive area where they would have more web applications or resources that they require, like online stores or online ordering, web app, hi. And so the way that we can divide it up, remember that we're going to treat them as individual networks within, right? So that means that we have to route all of the traffic across, right? I might have subnet 1 communicating with subnet 2, and in between, I want to have the router or the layer 4 switch connected between these subnets, okay? So when you do the packet tracer today, you're going to see that we are bridging the switches, and the switch is going to handle some of the traffic because they are layer 4 switching out. So anything that's above layer 3, that means that we can use routing and the next layer, right? So we want to be able to implement the devices that's appropriate for routing and controlling the resources for the network. Okay, so we understand that subnet is really about masking. It's about changing up the bits in the subnet mask. So that means that we have to take a look at how the IP address would have a specific subnet mask, like what we've talked about a few weeks ago, right? By identifying which octet is the network and which octet is the host. So in the next question, it tells you to take a look at the IP address 172.14.0.0. Right away, when you're looking at this IP address, because it ends in 0, you know that it is a network address. So the router uses the network address to kind of narrow down which network it needs to transfer that traffic to, right? It's kind of like, you know, how you need to take the train or the plane, right? You need to have a specific plane that's going to take you to a specific city. So the router, it's going to take a look at the network identifier, right? So in this, first thing we're going to say, this is a network address because it ends with the 0. This is not a routable address as in to a specific system. It cannot send that to a computer specifically, right? It can only say that, oh, it's part of this network. It's kind of like it's part of this town, but it's not sure which house, right? That's what we want. The router's job is to take the traffic and bring it into town. Remember, we said that the switch is going to take that traffic and take it to the home. So it's going to route it to a certain part of the network. So the first thing that you need to think about is what is its subnet mask by default, right? If I look at this IP address, I know it is a class B, right? We talked about class B by looking at the first octet. And class B range, so this is a class B. And so that means that with the class B, the classful address, the subnet mask is 255.255.0.0, right? So we know that the first two octets are network identifier and the last two octet are the host identifier. So I put out that it is network, network, host, host. So the first step, making sure that you know which class it is and the default subnet mask. We'll start from there. Then you can take your programmer calculator and you can convert each of the octet, right? Each of the octet into binaries. So if I take 255, I open up my calculator, right? And then I go to my programmer mode, select that. And then because octet are decimal, make sure you select decimal. If you punch in 255, right, you would have all ones, which gives me this one. For this, right, 255 is going to give me the all ones. And the same thing for the next octet for the subnet mask. Right? I can open up my calculator again and verify. 255 in decimal is going to give me all ones in binary for that byte. So far, so good, right? So the second step is to take the subnet mask and visualize it as binaries. But then, wait a minute. You said, well, but what happens to the 0 here? Right? So if we put 0, it will just be all 0, right? If we put, right, if we look at the 0 here, it will be all 0. But the question tells us that I need to take the existing IP and make it into 8 little subnetworks. 8 little subnetworks. So that means that I have to mask some of the bits and manipulate the first 0 here, so that way I can make that address into 8 small subnetworks. Okay. So the way that I'm going to do that is I'm going to borrow 3 bits. So I start with the 0, but then I'm going to tweak it now and borrow the 3 bits as I highlighted there. Why 3? Because if you take 2 to the 3rd power, that's going to be 8, right? If I take 2 times 2 is 4, times 2 again is going to be 8, right? So 2 to the 3rd power is going to be 8. And that gives me exactly 8 networks. So if you look at the question and if it tells you, oh, I need 16 subnetworks or even 15 subnetwork, you can have extra, right? Your network engineer said, well, we're going to divide this up into 15 subnetworks because there's 15 stores, okay? So that means that I need to borrow 4 bits, right? 2 to the 4th power is going to give me 16. Even if you need 15, you can go 16 because you just have 1 extra. Okay, so we're okay with that. Any question? So if I need 3 networks, how many bits am I borrowing? 2, right? 2 to the 2nd is 4. Okay, so after we understand the default subnet mask, we visualize our subnet mask in binary. And we ask ourselves, what can we borrow into the octet so that way we are going to be able to take 1 network and make it into 8. Okay. Remember that you start with 1 address, but now you're going to divide that into 8 division. So I need to borrow 3 bits. Okay. And let me type this out. So we need to borrow 3 bits. Why? Because it's, if you take that, you raise it to the 3rd power, it's going to give you 8 subnet. And that represented here, right? Because with 0, 0, 0, that's really the 0 here. But we're going to borrow the 3 bits to make it 8 subnets. And the 3 bits is the power, the exponent, right, of the base 2. Why base 2? Because it's binary. So are we okay with that? You grasp that? Because if you're lost here, it's going to be more difficult when we go to the next step and the next step. Okay. So the subnet number is going to be represented with the exponent and the base 2. Okay. So if you need 25, right? You just do natural log of 2. If you, or you would say 2 to the n is equal to 25. What is n, right? If you solve for n, that's going to give you the borrow bits that we need. Okay, so we're okay. Now, why did I put CIDR 19 here? Remember that we borrow the 3 bits, right? The 3 bits, this one. Because originally it's all 0. We're going to turn on the 3 bits in the host. We borrow that. And when we do that, we count up all the ones. If you count up all the ones, there's 8 ones here, right? Plus another 8 here, that's 16. Plus another 3, that's 19. So that means that I have a CIDR 19. There are 19 bits that are turned on. Okay? So if you understand the default subnet mask, and if we borrow the 3 bits, you just add those 3 bits to the bits that are on, which are these right here. So 16 plus 3 gives you CIDR 19. Yes. Because we need 8 subnet from 1. So let's think about it, right? Like we have 1 IP address for the whole entire network to start. Let's say that that's how it was built in the 1990s. But now, because we have security and other things that we need, we take the IP addresses and we need to make that into 8 separate networks. And it's 8 because the company wants 8. Okay. Maybe if logically it's better for security if we have 8 networks. So to solve for 8, to make sure it's 8, we have to borrow 3 bits. Because this is the default subnet mask to start, right? The 255.255.0.0. You lean into this next octet. You turn on the 3 bits here. Why 3 is because 2 to the 3rd power is going to give you 8. If you need 15 subnets, 2 to the n is equal to 15. What is n? 4, right? You have 16 networks. So 16 is more than 15. So you're okay. If you have 100, you need 100 networks, you just solve for the n. 2 to the n is equal to 100. What is n? Right? So yeah, you can do natural log of 2 divide. Yeah. So divided by n, you're going to get, so this is going to be why 3? 3 is because it's the exponent that's going to give you 8 subnets. Okay. Are we okay with that? Good question. A lot of people don't know. A lot of the time it's like, oh, wait, why is it 3? Why is it 4? Why is it 10? Right? It's because it's the nth value that's going to give you whatever that they want here. Okay. So because remember that we started with the 0, we turn on the 3 bits and we included those 3 bits with the other 16. So that gives us the 19. Right? I have 16 right here. And then I added the 3. which gives me 19. So this is the /19. Okay, so we're okay right here. Next step. So now we have to say, okay, well, we have to calculate out how many computers we can fit into that subnet, right? Into these subnets. The CIDR 19 is there for a reason. We wanted to know how many systems, how many PCs, desktop, smartphones that we can assign IP to for our subnets. So the computation is you always start with 2 to the 32nd power. Why? Because there are 32 bits in your IP version 4 address. Okay? That's the total number of all the IP addresses for the 32-bit, right? The maximum. And we're going to subtract, right, the subnet CIDR, which is the 19. So 2 to the power of 19. There's a reason why we calculate out the CIDR, because it's going to be used in the exponent, right, to calculate the host. Remember that the 19 represents networks, right? The network ID, right? This is a network ID, right? This one, right? This one is a network ID. And we borrow the 3 bits into the host for the network ID. So that's the CIDR 19. So 2 to the 32nd power is the total of everything. We need to subtract the network to get the host, right? So we have the total of everything, 2 to the 32nd power, subtract the 2 to the 19, which is the host value, the network value, and I need to minus 2. Why? Because remember we talked about this before, an IP address at the beginning, which is the .0, and an IP address at the end, which is a broadcast 255 that we don't touch, okay? We cannot assign those IP addresses because system needs to use that to identify itself, what network it belongs to, and how it's going to send to all the other systems, right? There's broadcast and there's network. So we are going to eliminate those 2. It's always going to be 2 less. Okay, so are you with me so far? Is it confusing? Any questions? So if you take this, right, which is the total, subtracted the network number, right, and then minus the 2 IP that we cannot use. So if you look at the exponent of arithmetic, right, 32 minus 19 is going to give me 2 to the 13th power. You can plug that into your calculator, your scientific calculator, and then minus the 2, I come up with 8,190 systems or IP addresses that I can assign. So these are the number of IP addresses that I can give to all the connected systems. You get 1 IP per system, so I can have 8,190 systems connected that is going to obtain IP addresses or be assigned an IP address, whether it is dynamic or static, whether it is a printer or a PC or an appliance, a security appliance. Whatever it is, it has to be within that 8,190. And this is important for network engineers, right? Because you don't want to have 9,000 computers and then be short, right? We have to go back and then we have to subnet again, right? You don't want that to be the case. So when you plan out, so that means that if Walmart or a corporate needs to expand, like in a certain state, they have to really make sure that they accommodate all the retail systems and all of those things. Even if they contract that out to someone, their network engineer is going to say, hey, right, this is our IP scheme. This is how we're going to go with that. Internally, this is your IP addresses that's going to be connected. Your system's going to be connected and routed. Okay. Any question? So this steps involve that you take 2 to the 32nd, no matter what, right? Because there's 32-bit. you're gonna subtract 2 to whatever the CIDR that you have for the network ID from the previous step. Then you're gonna subtract another 2 because those are the 2 unusable IP address, the broadcast and the network, the .0 and the .255, and you are going to come up with the number of hosts. Okay. Is there a calculator that you can use for this? Sure. You can download the app and do that. Most people do for their daily IT stuff. But remember that application sometimes is erroneous, right? It is as good as its developer. So if the developer is wrong, then your result is wrong. This is really important to know because you might be doing this one day. So why do I care if I'm a security person, right? As a security person, you have to take a look at network layout because that's the first ground for flaws. You have to say, okay, well, is there a way that we can take this part of the network and separate it and segment it, and now we're going from maybe 4 subnet to 6 subnet or 5 subnets, right? And we have to take a look at, is that usable with the IP address that we have? So you have to work with the network engineers and the IT team to accommodate that. But we can't just throw them solution that they cannot achieve. The solution has to be achievable. That needs to be feasible for the organization, right? So it's important to understand this concept, even from an aspect of security, right? So if we take this, right, and we convert it to, if you take your IP address and make it into binary, if I take this, right, it's going to be equal to this. Okay, let me highlight that. If I take 172.14.0.0 and I convert each of the decimal, right, to binary, it's going to be equal that. And you can punch that into your calculator and get each part out, right? Like I take 172. So let's clear this out. Sorry, let's go to decimal 172. Right? I get this value right here, dot, and then I take 14, punch that in, and I get this value, and then the rest is 0. So if we look at the network address as given from the question, right, the IP address is going to be highlighted in teal there. Okay. So first step is to get the default subnet mask, visualize it as a binary in the second step, ask yourself how many subnets I need, and that's going to tell you the borrow bits in the third step. Take that and apply that so that way you can find the CIDR, right, for the borrow bits, which is the network IDs. And then in the fourth step, you calculate the number of hosts by subtracting it from 2 to the 32nd power. Now, yes.
So for the number of hosts that equation, that -2, does that correlate to the 2 zeros?
So it correlates to the beginning and the end of your IP address range, the .0, which is your network, and the .255. You know, the last octet. So when I say that, it's, yeah, you're in the right area. It's the last octet for the host. So you see how this 0, it's going to eliminate this .0 and the .255. We don't assign those. Those are just non-usable IP. The system used that to identify itself in the network and talk to other systems on the network.
So like a different class, like class C.
You still subtract 2.
Oh.
Yeah, you always going to have the 2 to the 32nd power. That's the total of all the IP addresses. And then you're gonna subtract 2 because these 2 in the range is forbidden. It's not assignable. Yeah.
For the class A, you'll have more availability for
Right.
since you're having more network than hosts.
Right.
Less network than
That's not, yeah, so the more network you have, the less hosts you have, right? It's gonna weight up because there's only 32 bits, right? So, yeah, you're right. So if you're using class A, because there's less network, you're gonna have a lot more hosts. This is why enterprises like using 10 dot because it's a class A. Yeah. So in class B, right, if we use this IP address, we have to think about the subnet. Now this CIDR will change if your subnet range or your subnet value change, right? Okay, so now the next step is because there are 8 subnets, we have to look at combination of how we would use those 3 bits. The first option, all of them are 0, right? That's how we start. The first 3 bits that we borrow here in highlight, right? The first option is if we have them all 0. Second option is 1 bit is on, right? Third option is the second bit is on, and so on, right? So you would see these as combinations on how the bits would change. And so the way that I do it is I always start with the right. So that one turns on and then I move that to the middle, right? And then, so you can track all your bits. So these are 8 variations that you can have when we're using those 3 bits that we borrow. And then at the end, I have all ones, right? So are we okay with this? This is why it's 8, right? 2 to the third is gonna give you 8, but these are the 8 variation that you're gonna. Okay, so now, and when I say network address, right, all the host bits are set to 0. We understand that. That's what you've seen right here, right? Your host bits. Okay. The reason why I laid this out, this is the way the textbook kind of presented, but it gives you the visualization, right? This is not the only approach that you can learn IP subnetting. There are tons of different tutorial videos and resources that you can read. For me, I'm a very visual person. I have to kind of see it so that way I can imagine it in my mind. So this is my approach, and I hope that it helps you see it. But there are other ways that you can learn IP subnet as well. Okay. So let's look at the IP itself, and we need to now come up with the IP addresses in each of the subnet, right? This table is to give you the range of the IP address in each of the subnet. Okay? So first, so I know that I have 8 subnets that I have to set up my IP addresses. And the first octet is always going to be the same, the 172, right? And the same thing with the second octet, because that's your network code identifier. So the 172 and the 14 stays intact. It's going to be the same in all those ranges. Okay? The third octet is when we are masking. We borrow the bits from that. So you can type out the 0 and the 1s, or you can just put the 14 in the second octet, right? So they stay the same for all 8 networks. And the first line, I put the original IP so that way I can look at the range on what IP I'm going to use from when to when. Okay. So the first combination, we said that it starts with all 0 for the third octet. The 3 bits that we borrow, they're all 0. That means that my fourth octet is also, you can keep them all 0 here, right? we're not looking at assignable address yet. We're just looking at the network portion of it. So that way we can come up with the network address and then the assignable address. So it's going to be 172.14.0.0 for the first subnet. That's the start, the network address, right? Right now, we're calculating the network address. So the first subnet, we're going to have 172.0.0. And you don't have to type out all the zero like this. I put this so you can see, right? This can be 14, right? And then the 0. Now, what is the network address for the second subnet? 172.14. Now, the second combination is 001, right? And if you take this value and plug it into your programmer calculator, you're going to get 32. You don't believe me? You can copy this. Pick your programmer calculator. Oops, looking at the screen. Right, go to binary. We're going to clear it. Let's see if I can paste it. And I have 32. Right? I simply take this value, which has the 3 bits manipulated for the second combination, right? The 001, which gives me the binary value here, which is equal to 32 in decimal. So the second subnet network address is this, 172.14.32.0 for CIDR 19. What about the third subnet? Well, the next variation, sorry, it's probably hard to see with the pink. I'll just do it as, I already used the gray, but let's just not highlight it. Right? It's 010. So if I plug that into the first 3 bits here that I borrow, and I take this entire thing and I plug it into my programmer calculator, right? Go to bin, clear, and we're going to paste it, right? Which is the value from here. I look at the decimal. It is 64. So it's going to be 172.14.64.0. You see the pattern? You're going to start seeing the pattern, right? So if I add another 32, I get a 96. If I add another 32, right, to that octet, I get a 128. Right? So the next combination is 011, and you take that binary value, plug it into your programmer calculator, you get a 96. That's your fourth subnet network address. Okay. Why is this important? This goes into your router. This network address is programmed into the router. This is how the router would know where to send that to. Like which city to take you to. Right? And then the switch would take you to the home, which is your computer. Okay? And then the next combination is 100. You plug that into here. You take this whole entire thing, put it into your programmer calculator. You should get a 128. And then the next combination, right, which is your 101, put that into here. Take the whole thing, put it into your programmer calculator. You get a 160. And so you see the pattern. I take 32, add it with 32, I get 64, 64 added with 32. For this, for the 8 subnets I'm working with the CIDR 19, it is 32 indifferences from one to the next. Now we haven't done the exclusion with the 0 and a .255 yet, right? That's just your network address. And then I would do that repeatedly, right? So the 110 here, put that in, I get a 192. And then lastly, the 111, put that into the first 3 bits. I should say the last 3 bits because it's right to left. I get a 224. So on the 8th subnet, right? This is the start of it. This is the network address for it. Okay. So once you have the variation in your borrow bits, then your next step is to come up with your network address. And you guys are expected to know this for finals. So practice, okay? All right. So I put here when I did the explanation last year when I taught this class that now let's think about usable IP addresses, right? We know that the edge router is going to be .1. That's things coming into the network. That's the first device that you see logically, right? That router is going to take it to other area of the network. So your first subnet router, I'm looking at subnet 1. Look at its network address, right? 172.14.0.0. So I'm going to keep the 3 octet the same, and I change up the host value. It's going to be .1, right? Then the second subnet router, I take a look at the network address, which is 172.14.32.1. Why is it .1? It's because this is a .0 for the network address. So my example here, let's say that you have an internal firewall, you have a router, then the next appliance that the traffic is going to hit is going to be your firewall. It's going to be a .2. And then let's say that you have an uplink switch, a layer 4 switch, that the distribution switch, that's going to be a .3, right? And then you might have a few servers. So I normally dedicate like .10 to, .20 something servers, depending on how many. So the last host octet here is going to be increment as you're looking at assignable IP addresses moving in from starting with a router, which is a .1. Okay? Question. So this is kind of like an example of you thinking out, okay, so how's the range? We already have the network address. We can start now putting together our ranges. If you're unclear, please ask question. And if you don't want to talk about it now, you can see me during office hours or outside of class, because sometimes this is hard to grasp, right? All right, so we're good with this, right? We can understand a little bit on now, where do we start with the router and where do we assign IP addresses to the other appliances that we have? Next part. Move to the next page. So now what we're going to do is we are going to think about the range of IP addresses that we have to work with, starting with the router and moving all the way to the end of that, each of the subnet. So I put down that you would then put in the first IP address that you can assign. You just turn on that 1 bit on the right? This 4th octet, if you convert it all to ones, here on the least significant bit, your LSB, you have a .1, which is normally our gateway or our edge router. So I have 172.14.0.1, 172.14.32.1, 64.1, 96.1, 128.1. So once we have the network address, the next usable is gonna be a .1, right? Another usable after that is .2, .3, .4, .5. But where does it end? So that will be the next part. So we now have a starting point for a usable IP address, which is normally our gateway. So you have to know that the second octet is 14, right? It stays the same. You can type 14 or the binary equivalent. The third octet also stayed the same throughout. Oh, I'm sorry, not stay the same. It changes because we borrow in the host portion. So the first one is 0. The second one is 32 and so on. And then the fourth octet is going to be the individual systems, right? The .1, .2, .3, so that changes. But the first appliance or system in our network, first usable IP address is going to be this for each of the network, the subnets. So after you have come up with the network address, you would then think about what is going to be my first assignable or usable IP address for my gateway or for the edge appliance to my network. And so this is why normally, right, I have you type in the IP address with the .1 because that's usually the default gateway for your network. It's just a practice that, you know, logically, when you're looking at the layout of the network when you first started this class, right? You have the router, and that's connected to the cloud, which represents the internet. That's the first system that you see coming in from the outside. It's like your front door or your gate to your home, right? It's a .1. And then after that, if we have another system, it's a .2, another system, it's a .3, and so on. And then down the line, we might have 100 system later, right? Your PC might be 101 or 170 or etc., right? Up to 254. Because we don't use 255. Okay, 6. Only one question. Are we okay with this? So now you have the first IP usable address, right? Then next, we're gonna find the last usable address, right? Because ultimately everything in between is usable. Okay. So I put down on the bottom of that chart, it says determine the last valid usable address. The least significant of the host bit is set to 0. And the rest of them, the others, right? So when we say that, remember that when we did the first usable, this is to turn on to 1. But for the last address that's usable, this is going to be 0 and the others are going to be 1s. It's reverse. Okay. So the first subnet that when you look at this, right, you're going to convert the last bit on the right-hand side, that's the least significant bit, to 0. You flip it to 0. And the others, you turn that on to 1s. So if you put that into your programmer calculator, you are going to get 254, right? But we cannot forget the third octet. Okay, this is important. I want to highlight this. Remember that it starts from here, right? And the next, remember that this is 0, right? And .1. But when we go to the next subnet, it's 32.1. So it's gonna go from 0 all the way to 31, 254. Okay, so the range is gonna start from here. It's gonna end right before 32. Okay, so you have to take a look at the third octet for the ending of that range. Okay, so we established that we turn on the 0 and the front 7 bits here is going to become 1s. That's going to give us 254. But we have to take a look at how the bit right before that. So for the third octet, the first 3 bits is going to be off, right? Because remember, that's the combination, the first combination that we established. And the rest of the bits are going to be on because this is the end, not the beginning, right? So we are going to keep the borrow bits as 0. And the rest of them, you're going to turn them on. And this is going to be equivalent to 31. Okay. Math doesn't lie, right? So if we establish that the 3 bits that we borrow is 0, but because it's at the end, so the last 4 bits on the right is going to be 1s. Those are going to be turned on because it's the end, not the beginning. At the beginning, they're all 0, right? But at the end, we're going to keep the borrow bits the same, and then everything else is going to turn on to 1. For the right-hand side octet, the last bit is going to be 0. Everything else is going to be 1. So that's how we got 3154. So 172.14.31.254. That's the end of the first subnet. It starts, right? You look at the previous table, it starts at 172.14.0.1. That's the beginning. And the end, it's going to be this. So that means that it's going to go 172.14.0.1, and then eventually it's going to be 172.14.1.1, right? .2.1 all the way up to 31.254. And we repeat the same concept for the subnet 2, right? You turn the least significant bit to 0, and you flip the other bits from 0 into 1, and you also get 254. We don't use 255, right? And then you check, because the subnet mask, the borrow bits, right, 0, 0, 1 stays the same from the earlier steps, and then everything else turns into 1. So when you plug this into the programmer calculator, you get 63. It's right before 64, right? 63 goes before 64, so it's going to be 63, 254. And you started to see the pattern. It's going to be right before that network address for the second subnet, or the third subnet, or the fourth subnet, and so on. That octet. So the end host bits are going to be 254 here. And what you're going to do is you're going to subtract 1 from the starting value, the third octet, right? So you get 31, 63, 95. Instead of 96, right, 127 instead of 128, and 159 instead of 160, and so on. And it's basically a pattern because it represents the increments in from one network to the other. So mathematically, you do see a pattern in from a chunk to the next chunk of IP address, one subnet to the next subnet. And at the end for our subnet 8, right, we'll skip forward there so you can see. I'm always going to have 254 for the last octet because that's the last IP address, last usable host IP that I can assign. And if we turn on, because remember on the last combination for our borrow bits are all ones. And if we turn on everything all ones, I have 255. Well, that's okay because this, right, that this third octet, it doesn't represent the host. It actually represents network still, right? We borrow in that octet for network. So 254 is the last usable IP address for that range. So your job is to come up with usable IP addresses for all these subnets, right? In this case, we have done 8 subnets. We started with a network IP address that we're given and a number of subnets. So you always think about that. That's going to give you the base and how you're going to be able to calculate the CIDR, right? Your subnet ranges, where it's going to start and where it's going to end, is how many subnet you need and what is the IP address to start as a network address. Those are the only 2 things that you need. Everything else, right? We learned that it stays the same for all calculations. Doesn't matter how many subnets you have. Question. So this is gonna take a little bit of practice, right? Like I said, realistically, we'll use a calculator for this, but you should check the calculator's result to see if it's accurate. But having this knowledge is important, right? So if you put that on your resume, right? Manage TCP IP network and subnets. Calculate IP subnets or in that variation. It should catch some attention because most network admin, they look for those things. Okay. So now we're going to look at the non-usable IP address, the broadcast address. This is after the usable IP address. This is the end, right? The IP address that it uses to send to all systems, that's really easy. If everything turns into ones, all you have to do is add the 1 to the 254 and you have it. So there are .255 for after the last usable assigned IP address. This is used, but it's for broadcast purposes. So you just do a +1 to the previous set, and you have the .255. They are all ones. So the router is really simple, right? It doesn't look at decimal value like this. It's just check how many bits are on and off. And that's how it determines quickly where is your town, right? Where is your network? Which network? By looking at which are on and which are off. So when it sees all ones, right, that's a broadcast address. Send to all. And again, you don't have to type in the 0 and 1s. I only do that so you can see them as binary, right? You can say 172.14, right? The only manipulation we have was the 3rd and the 4th octet for this exercise. In some exercises, you see that it is also the 2nd octet if it is a class A. So in this case, right, we are class B, but we lean a little bit into class C, isn't it? On the 3rd octet, we borrow into that a little bit. So this is a way that you can mask bits, or what they say is subnet, right? Subnet is a way that we can mask some of the bits and utilize some of the bit as part of the network bits. Now, most of the modern system, you type, when you configure, right? You type in like a router, you type in the network address, which is the .0, and then the CIDR, which is represent the subnet mask. And if you are not using a classful address, if you type in CIDR 19, the system understand that those 19 bits are on, and it's gonna look for that. That's what it's gonna look for, right? And then the variations of this is going to be, so we can set routes that way. Which router is handling which path? It's kind of like you configure your Google map to travel a certain way from point A to point B. And that's how you're going to be able to go from home to work or home to school, or you would have variations of ways. And so what you would have is ultimately Google Map is going to ask you, right, some form of address or like a zip code to kind of narrow down on how it's going to either take you through the freeway or take you through the regular road. Okay, so it needs to get you to the network, right? That's the router's job. Any question? Right, so we've done 8 subnets in this exercise, right? We've also come up with network address, usable IP address range for each of the subnet, and also the broadcast address at the end. Sorry, let me move this up a little bit. And unfortunately, these tables are kind of large, so. So when you write it out in one summary, right? This is like maybe included in with your network diagram at the end. For your logical network diagram, sometimes we can't add in all the addresses onto the diagram. We would attach a page. So here's the breakdown, right? We started with an IP address. We came up with a network address. From that, we came up with the first usable address, which is from its variation, and changed that bit to 1. We came up with also the last usable IP addresses by flipping the 0 and the 1s on those octets. And then, and lastly, we came up with the broadcast address, which is that that 5th column. And so, how are we going to write out the subnet mask? So we started with 255.255.0.0, but because we borrowed the 3 bits, right? If you plug that in for the borrowed 3 bits, for the CIDR 19, if there's 19 bits that are on and you punch that into your calculator, right? That's the number of hosts that you have, which is this. I'm sorry, the number of networks. Addresses.
Do you think that's the last Google thing?
This one?
That's the last one.
So for the 224, remember that on the last combination, right, we have so we cannot use this, and different than this, right? Remember that the new subnet mask is going to represent the borrow bits into that host bit, right? Why is it 224? So if you punch in the 111.0.0, this is part of your Remember, we borrowed the 3 bits. If those 3 bits are on, out of the 8, right, we get 224. Yeah, Brandon.
There's a mistake on the, network address column. The,
Oh, yeah, the second one, the subnet 2. That's correct.
all the right kind of shit together.
Yeah, so 32. I might have highlighted. This should be 32. I apologize. Yeah. And then they kind of have the domino effect. 64. Change that to 96. It should match 128. Right? It should match with these. And then 160. Thank you for catching that. 192. And then 255, right? Sorry, I'm tracking. 224, the 32 in between. So yeah, 192 plus 32. Should match with this one. Okay, so we would have the usable IP, I mean the number of hosts. We calculated that earlier, right? 2 to the 32nd power minus 2 to the 19th power minus the 2 unusable addresses. We have 8,190 hosts per subnet. So altogether, we have many, many computers, right, for this 8 networks, but not compared to a class A address, of course. But for like a medium to large size business, this is adequate. You can have a number of systems, a good number of systems for the locations. Did I?
Yeah, very last one, is a 254 on the broadcast.
This one. Let me save. Yeah, so broadcast should all be 255. For this case, yeah. Usually you see that as a broadcast as well. So when you see a borrow bit or a mask address like this, we know that is a classless address. It doesn't quite belong to full class B, right? We borrow into the 3rd octet, so it's classless. It's not an exactly the default class B address. Now some addresses are classful where it is by default the same class. Like the 10, in the question 3, what you see is like this. So if I see a 10.0.0.30, this is a usable address for class A. Well, I know it's a class A by looking at the first octet. It is 10, so it's the first range. That's a class A. And I look at the subnet mask. If it's 255.0.0.0, it matches the class A subnet mask. That is a class full address. It's a default class address, right? Now, when I look at question B for number 3, 141.18.0.19, and I know that 141, right, B, but look at the subnet mask, it's 255.248.0. That's a classless address. classless address because it doesn't quite belong to B or C, right? It's kind of in between. So, you know, it leans more into C, but this is when you know that they subnet mask. They use a subnet mask to mask the bits, to borrow the bits into the C. Okay? So classless address simply represents that we use an address to create other subnets. It doesn't quite belong to a specific class. That's called classless address. And for C, right, same thing. Okay? So when you look at 204, that's a class C, but when you're looking into the subnet mask, it's not exactly 255, 255, 255.0. It is a modified subnet mask. It's not a default subnet mask. So the 192 is not a default subnet mask here. So it is a classless address. It doesn't belong to specific defined class. So we need to distinguish between a classful address, which is using default subnet mask, or a classless address, which uses modified or mask, right, bits in the subnet mask. And then lastly, question D for number 3, 48, 255, 255, 254, using subnet mask, 255.0.0.0. It is a class A, right? We know it's a class A because the first octet is in the first range and it uses the default subnet mask. So to answer this question, you ask yourself, what the first octet, which class is it? Does it match the default subnet mask? If it does, it is a classful address. If it doesn't, right? If it has like 192 or a different number in the octets, then it is a classless address. Simple. Okay, so now we're gonna shorthand the subnet mask by creating the CIDR. Are we okay with this? I don't wanna like speed up too fast if you're still working on certain things. So I tried making my students from last time that I taught the class watch the video on their own in 3 parts. When they came to class the following week, none of this was filled out. So I had to switch strategy and I said, well, you know, even if we run out of time, they can probably do packet tracer on their own with the video. But I think having the opportunity to listen to the lecture live and then ask questions when you need to, probably is more effective. So I went back to lecturing this part. So if we don't have time to do the workbook today, I will extend the due date. I think I'm going to give you guys a couple of weeks to work on that for the extra credit. I will give you a little bit of time to explain it next week. Okay. Okay. Any question? Okay, so let's work on the CIDR. Let me flip to the notes. So in the notes, right, like I give the breakdown, the table, all of that, what kind of what we talked about, but using a different IP address. So you can go through this again. And I think I have a lecture video. I'll try to repost it onto your video page for this week so you can see how this worked out. You can follow along with that if you like. Still the same process, right? Putting the CIDR, converting, looking at the host bits. And then classful and classless IP address is on page 3. So kind of important to highlight, and I didn't put this into the questions. Your classless routing protocol include your VLSM. You see this in some configuration. Um, and so when you're working with like a subnet mask that is used with the mask bits, right? This is gonna be represented with the VLSM protocol. And then classful routing, it's just simply looking at your subnet mask that would belong to A, B, or C. Okay. So for the classful IP address, it does support VLSM, but in some routers, I think now they use RIP2. RIP1 has vulnerability, so I think a lot of the vendor move away from routing for the RIP using RIP as a protocol. And in the future weeks, you are going to configure this, right? It depends on the appliance whether it supports a certain version of the protocol. So if you have an old router, it might still support a certain type of protocol. So if you're using a classful address, right, normally you would have to use RIP1 or IGRP. And we'll come back to some of the protocol stuff down the line. And then for the classless, right, it would then be used as VLSM. You would use RIP2, IEGRP, or open shortest path first. So these are just the way that the router deliver traffic. Sometimes it waits based on the distance. Sometimes it would wait based on. So there's various calculation or determination in the decision-making process depending on the protocol and the type of protocol, right? But if it's classful, it's a certain type of protocol is supported, and it's classless, it's certain type of protocol is supported. And then when you set up forwarding, like in the case if you use your wireless router to port forward or forward to another system, so I can have, like, if it's this type of traffic, forward it to router 4. If it is sensitive traffic, route it to router 5, where there are security appliances to check that traffic, right? Or I can port mirror, do other things. So forwarding can play an important role because sometimes router doesn't just send it directly to the destination, right? It sends it to other routers to get it to the destination. So if you use forward routing, you would use the default route for the classful. Also, there's no restriction for the default route if you're using classless, right? And then for CIDR, just we use this to integrate classless interdomain routing. It is a way for us to use the subnets as a shorthand indicator using a slash value. That just represent the bits that are on. Okay. So coming back here, let's go through number 4 together. Determine the CIDR for the following addresses. You're getting the 10.0.0.30. Its subnet mask is 255.0.0.0. This is a classful address. So we are going to look at the subnet mask. The 255 represents 8 bits that are on. So that one is easy, right? The 8 bits is going to be CIDR 8. So the slash and the number, that number just represents the bits that are on in the subnet mask as binary. So if I convert 255 into binary, I have 8 bits, and that will be /8. Question B, 141.18.0.19. And when we look at the subnet mask 255.248.0, so we need to break this down into how many ones are in each octets that are on. I mean, how many bits are on? Yeah. So the first one, you have 8. The second octet, you have another 8. So that's 16. And the third octet, right? If you convert that into binary and count up the ones, you have 5 that are on. So you add up the how many ones you have in this subnet mask that represents the on bit. You have 21 bits. So all else fail, take that decimal, convert it to binary, count up the ones, and that's what you're gonna have. Okay? And then I add up each of the octet and I have my cider. Easy?
Whenever you just decide it's always gonna be the front. Like, whatever, it's up to the rest of zero on the right side, right?
Yeah, we don't, yeah, 0, we don't, there's nothing on. Only the bits are, these represents the number of ones are on, so. And then you can reverse it too. Some people, the way they think of it is 255, all the ones are on, and the difference in that, right?
That's why I did, I got
Yeah.
7, so 7 carries the first 3. So.
Yeah, some people, yeah, it's the brain works that way. They flip it. Sometimes I think about it that way too, but if it's easy for you, but this is traditionally how we look at the number of bits that are on. Okay, third question for number 4C. 204.110.0.193. The subnet mask is 255.192.0, right? So you look at the subnet mask here, the first octet, that's A. The second octet, that's another A. And then the last octet, if you convert this into binary, you see that there are only 2 bits that are on. So you have 2. So 8 plus 8 plus 2 gives you 18 as a cider. And then lastly, this one is easy. Just like A. So this is a class A IP address. It is a class full IP address because it uses the default subnet mask and it only has 1 octet with 255. So that is only going to be 8 bits and the rest are 0. So we have a cider A. So like I said, some of the appliances, you don't need to type out 255, you just put in the slash and the 8. I think on Linux system or some of the applications for server, that's what it wants. So you have options in typing out the full subnet mask or just put in the cider for most appliances now, which is nice. Because, when you configure 150 system or 1,000 system, typing out 255.0.0.0 can be tiring, right? But we automate some of that too. So you can create a text table and then you can parse it through CSV and have it automated with Python. Definitely. So it plugs everything into all your new routers for you so you don't have to configure each one, right? Why? We have a machine that does it for us.
Pretty much, they just pretty much put like the start and the finish.
Yeah, and loop it. So it would say, like, how you issue the same command, right? Like you would do config term and then all of that. You can write that using OS library and then have Python plug in the command for you. For each of the routers, like let's say I have to name the router, put in an IP address, and then update its password or whatnot. Yeah, if you have to do that for 1,000 system, who has time? Who wants to do that manually? Come on. So yeah, so you just do, and you just gotta make sure that it sees, right? And so you have that automated and configured. You can also, because we use network management protocol to do a lot of things. So once it sees your system, it's able to configure your system so you can have an application to do that. Yeah, that's money automation. And that's with cloud and data center too, because, you can have a lot of different system configure. All right, 5. Identify the type of routing algorithm based on the following scenario. I'm gonna try to, can I move 5 to the next one? We're done with 4, right? Okay. So for number 5, A, Node sends information from point A to point B via a path that results from lowest total cost, lowest total cost, right? So, let's put this into the daily use. Let's say that you go to Google Map and you find, trying to find direction to go from your home to a restaurant. And it's gonna give you 3 routes, right? So the algorithm for the application for Google Map is gonna give you the shortest route that's gonna take the least time, right? Because as human, we want the less time to travel when we need to drive the car. So the router does the same thing. Sometime it would calculate the total distance, like, if I send it this way, if I go this way, it's gonna be 2.4 miles. But if I go direction B, it might be 3.1 miles, right? So we want the shortest or the lowest total cost for that path. So this is a distance vector, and it basically look at each of the distance and sum that up, like the total number of miles that from your house to a restaurant, right? 2.4 miles or 3.1 miles. It's gonna pick the 2.4 miles for the lowest cost, right? Because that is just a vector that it calculates. And what it does is it gives a numerical value to each of the distance or the vector that it's able to compute. So when it does that, basically it does the sum. And the router, it has a comparison table where it says, oh, this route is going to be higher cost than this route. It's going to send it this way. And you see this with autonomous system that we see as what represents the internet cloud or the network, the internet networks that we have, right? So there's distance vector. And then for B, it says to produce its map, the node floods the entire network with information about other nodes that it can connect to, linked state algorithm. And I call this the nosy neighbor, right? It's kind of like imagine that router is going to say, hey, who's available? And it's going to send that out to all of the systems that are connected to it. And it's going to wait. And the other system is going to report back, and then it's going to say, I'm available, I'm available, I'm available. Choose me, right? And or it will scope out all who's available, and it's going to pass it to that. So it's looking at the state that's able to link, right? So it's going to check with the other to connect based on the state. If it's not available, not gonna link, right? And then you have the border router that advertises definition to reach its neighboring router, which is your path vector algorithm. And this is kind of like, it's gonna tell all the other routers, is gonna say, I'm the best. I'm gonna send, right? Make sure that you're available. And so all the other routers is also going to say, choose me. And so it's going to send that to the neighboring router. So these two are similar, right? This one is going to broadcast to everybody. It's going to say, I'm ready to send, right? Who's ready? And then the one that reports back is going to send. But the C, the neighbor routers is going to say, me first, me first, me first. And it's going to pick the ones that advertises to it that is most convenient. Okay. So the point to this is make sure, right, for certification and practice, make sure we know our differences between these, right? I put it all into a few words, but you need to go through this and read through it. The difference between distant vector, linked state algorithm, that could be important for your certification or interview if you're trying to get a job in that. If you're familiar with, like, I think some of you have taken discrete structure with me, or if you're familiar with graph, in computer science, this has a lot to do with that, right? It is either computing and how it traverses through the map. And this is because the router ultimately have a decision point in how it's gonna go through a certain path and which one does it choose. So There's optimized link state with the routing table for OLSR, and then the path vector protocol. This is what we talked about here. So it is, these two are for intra routing domain that's within the internal network. So let's say that we talk about subnet, right? Subnet 1 to subnet 2. Distance vector and link state are ideal for those. And then for the path vector, you can also use, so this is when I go from one network to another, like from my network to my service provider, path vector is ideal. Okay, it's kind of like taking the freeway versus the small road, right? The intertown in the small road, we're going to do link state and distance vector, where path vector is like when you're traveling from here to Orange County, kind of, right? Like you have to enter another city. So your path vector routing is good for inter-domain routing, where the other ones are intra-domain routing. So you see that with autonomous system. Those are your routers that you see for all the internet work, what we say the internet, and so on, okay? And then some terminology, you need to take a look at loopback interface, routing loops, routing tables, default route, etc. So make sure we go through these. And also on how dynamic routing protocol works. So some routing protocols are used for static routing, and routing protocols are used for dynamic routing. Dynamic routing is going to choose whichever way that's ideal to route, where static routing, it's kind of like you setting to drive from home to school, and it's the same way every single time. You're going to turn right on the street, left on the street, and then, you know, at 3 stop sign later, you're going to turn right, right? It's the same route that it's going to send from source to destination, where dynamic routing, it might go one way, the direction A, or direction B another day, right? Depending on the availability of the system and so on. So protocols are able to handle that. We talked a little bit about RIP. There's version 2. And then for the interior gateway protocol, your IGP and RIP falls under that category. And then there's EIGP, which is your extended, and then, so if open shortest path first, it's just the shortest path, like the shortest way that you can get from work to school, right? Okay, so take a break. I'll pause this here and then make sure we go through the notes when we have time.